Hello dear student, welcome to another lecture of engineering mechanics. This is lecture number 4 and in this lecture we are going to talk about force systems. We are going to learn what are force systems and how to find the resultant of force systems. But before starting with this lecture, let's have a quick revision of the last lecture. And the last lecture was about moments. We learned what is moment of a force and the scalar and vector formulation of this moment. Then after that, we learned the moment of a couple. When two equal and opposite forces are acting parallel to each other, they cancel each other and they form a couple. And then we saw a very important theorem related to the calculation of moment, which was what? Varignon's theorem. According to this theorem, if you can't find the moment of a force, then resolve that force into two components and find the sum of the moments of those two components. So this theorem helps us to calculate moment of forces in lot of questions. We solved many questions based on this theorem. And in the last lecture, I gave you an assignment to solve. Let's see what is the answer to this question. Find the angle theta in degree for which the moment of the force F at point A is maximum. So we have a frame which is subjected to a force of 6 kilonewton acting at an angle theta from horizontal axis, and we need to find at what value of theta moment of this force at point A will be maximum. Now how we are going to solve this problem? First, we are going to resolve this force into two components. So let's resolve this force. So this is going to be the horizontal component. Let me make it a bit thicker. Yes, now it's perfect. And this is going to be the vertical component. What will be the horizontal component? As it is making angle theta with the force, it will be 6 cos theta. And what will be the vertical component? It will be 6 sin theta. Now what we are going to do is, we are going to find the moment of these two components at point A. So we will get the equation of moment in terms of theta. Yes, of course, civil students can also attend this lecture even if you are from other branches. This is not only specifically for mechanical, this is for all the branches which have engineering mechanics in their syllabus. And it doesn't matter for which exam you are preparing. GATE, engineering services, civil services, SSC, AE, JE, semester exam, doesn't matter. If engineering mechanics is in your syllabus, you can attend this lecture because these are all basic concepts which are asked in every exam. Okay, chalo. So what we are going to do is, we are going to find the equation of moment at point A in terms of theta. Okay, so let's calculate the moment at point A. Now the moment of 6 sin theta and 6 cos theta both will be clockwise. How do I know this? I will put the thumb at point A. I will point this finger towards the force 6 sin theta and I will move the finger in the direction of 6 sin theta. See, clockwise moment. Similarly, I will put the finger towards 6 cos theta and I will move the finger in the direction of 6 cos theta. See, again clockwise moment. So both the forces are applying clockwise moment. Now, what will be the moment of 6 sin theta? It will be 6 sin theta multiplied by this distance. Now, what will be this distance? This distance will be equal to 3 meters, right? The radius is 1.5 meter. So this is the diameter of this semicircle. So it is going to be 3 meters. So it will be 6 sin theta multiplied by 3. Then the moment of 6 cos theta is also in the same direction, clockwise. 6 cos theta multiplied by distance is 6. So this is the equation of moment in terms of theta. Now you can see that this moment is a function of theta, right? 18 sin theta plus 36 cos theta. You can see that this moment is a function of theta. It means that it is going to vary with respect to theta. It is going to vary something like this. If I draw a curve between m and theta, then it is going to vary something like this. Okay, and I am just giving you an example. I am not drawing the exact curve of moment. I am just giving you an example. Okay, so if I put theta equal to 0, then you can see that sin 0 will become 0, cos 0 will become 1. Na? So you will get some moment. So even if at theta equals to 0, the moment will have some value. Now this curve is going to be like something like this. Something like this. Okay, something like this. I am not drawing the exact curve again. Don't get into this that how this curve is going to be like this, it will be like this and this. I am just giving you an example. So it will be something like this. Now you can see that at this particular point, the moment MA is maximum. Right? At this particular point, the moment MA is maximum. So at this point, what will be the value of the angle theta? How we are going to find that? You can see that the slope at this point is equal to 0, right? Wherever the moment will become maximum, the slope at that point will become 0, means dm by d theta will be 0. So all you need to do is differentiate this with respect to theta, dm by d theta, you will get the slope, equate it with 0. So wherever the moment will be maximum, the slope will be equal to 0. Okay. So dma by d theta equal to 0. Now what is ma? 18 sin theta plus 36 cos theta. So it will be d by d theta of 18 sin theta plus 36 cos theta. Now if I differentiate sin theta, I am going to get cos theta. And if I differentiate cos theta, I am going to get minus sin theta. So it will be something like this. So it will be 18 cos theta equal to 36 sin theta. So 18 by 36 equals to sin theta by cos theta, means tan theta will be equal to 1 by 2. So theta will be equal to tan inverse of 0.5. So what is the value of theta? Tan inverse of 0.5. I am getting 26.56 degree. Very good, very good, very good. Very good, beta. 26 point. Sanjay got the answer. 26.56 degree. So this is the answer. 26.56 degree is the angle at which the moment of this force is going to be maximum. I hope that you learned something new in this question. You have this type of question in one of the exam, 𝐂𝐸. In 𝐂𝐸 there was a question like this. Okay, chalo. So this was the last class assignment question. Let's move on to today's lecture. In today's lecture, we are going to learn about force systems, what are different types of force systems, and then we will see how to calculate the resultant of these force systems. Very important question. You might get direct questions from this concept, finding the resultant of force systems. Okay. So let's first understand what are force systems. Usually, whenever you consider a member, whenever you analyze a member, it is subjected to lot of forces. Why? Because every member of a machine or a structure is connected to multiple bodies. For example, consider any one member of the structure of your house, a beam or a column. It is connected to multiple bodies. It is interacting with multiple bodies. So it is subjected to multiple forces, right? Now when I analyze this single body, all these forces which are acting on the body can be collectively called a force system. Whatever forces, let's say there are 5 forces acting on the body. So all these 5 forces collectively as a group can be called as a force system. Why we are calling it a force system? Because there are different types of force systems based on the nature of how the forces are acting. And based on different types of force systems, there are different ways of analyzing them. Let's see what are the different types of force systems. So broadly we can classify the force systems into 2 categories: coplanar force systems and non-coplanar force systems. What do we mean by coplanar force system? By the name itself, it is very clear. Coplanar means all the forces lie in a single plane. You can write it down. All forces lie. I hope that I have written the spelling of lie correctly. In a single plane. And in non-coplanar force systems, forces lie in different planes. Now practically coplanar systems do not exist. Practically all force systems are non-coplanar force systems. But in some cases we can assume a particular force system to be coplanar in order to reduce our calculation time. This assumption makes our calculation easy and the result is not affected too much. You don't get a lot of error. Let's say you are getting only 1% error, but your calculation time is reduced to 50%. So you are going to take that chance, right? You will assume that this system is a coplanar force system. Let me give you a perfect example. Let's say we have a car. Let's say we have a car. We want to calculate the reaction forces on the wheels of this car. What do we want to calculate? We want to calculate the reaction forces on the wheels of this car. Now, how many wheels does this car have? This car has 4 wheels. But when I draw it in a single plane, then the front wheels will look like this. You will see only one single wheel, and rear wheels you will see only one single wheel. So when we calculate the forces, we assume that all these forces are in a single plane. Actually, does it have only these many forces? Is it a coplanar force system? No. Actually, it is a 3-dimensional force system. This wheel and the wheel behind it are in different planes. This wheel and the wheel behind it are in different planes. But in order to simplify our calculation, we are assuming that all these forces are lying in a single plane. So how does this help us? It makes our calculation easy and the error is not too much. It is a very small error. Let's say 1% error. So that is why it is convenient for us to assume that it is a coplanar force system. So actually, practically, it is a 3-dimensional force system, but we are assuming it is 2-dimensional. Okay. So coplanar force systems are 2-dimensional force systems and non-coplanar force systems are 3-dimensional force systems. Practically all force systems are three-dimensional only, but in most of the cases we assume it to be a two-dimensional force system so that it makes our calculation easy. Are you getting my point? Are you getting my point? Why we are assuming the forces to be coplanar? I hope so. Yes. Now, in our syllabus, we only deal with coplanar force systems. In our syllabus, we will only deal with two-dimensional forces. We will assume that all our forces are lying in single plane because we only can draw two-dimensional forces, right? It is very difficult to analyze three-dimensional forces on a two-dimensional plane. Okay. So in our syllabus, we only deal with this type of force system, coplanar force system. Okay. Now, coplanar force systems are also of different types. We can divide them into four categories. Whatever force system we will study, we will only study coplanar force system, but we will divide them into four categories. Coplanar collinear force system, coplanar parallel force system, coplanar concurrent force system, and coplanar non-parallel non-concurrent force system. Now, some of these force systems are very easy to understand just by their name, like this and this, but this one you will not understand by its name. Let's one by one understand these force systems. So first we will start with collinear force system. So what is a coplanar collinear force system? By the name itself it is clear. Collinear means what? The forces are in a single line. So let's say we have a rigid body which is subjected to forces which are passing through the same line. Let's say this is the common line of action of the forces, and the forces are like this. This is one force. This is another force. Both these forces have the common line of action. So this type of force system is known as a coplanar collinear force system. All the forces are lying in the same line. Their line of action is same. Practically, can you think of an example of a coplanar collinear force system? Can you think of an example? In your childhood, you might have played this game of tug of war, where two groups of people hold the two ends of a rope and they try to pull the other people towards them. Tug of war. So in that case, if you are pulling this rope, this is one set of people, this is another set of people, they are pulling the rope. So the two ends of the rope, they are subjected to what? A collinear force system. Yes. Now in your syllabus, you will hardly see a question based on this force system. Why? Because it is very easy, right? It's very easy. So you will hardly see any question. I don't think that there is any question based on this force system in any exam. It will be too easy for us, right? So let's move on to the next force system, which is very important for us. Coplanar parallel force system. Now by the name itself it is clear. What do we mean by coplanar parallel force system? According to this force system, all the forces will be parallel to each other. Their line of action will be parallel to each other. They will not intersect at any point. Okay. For example, let's say all the forces are in y direction. This one, this one, this one, all forces are in y direction. So you can say that these forces are a coplanar parallel force system. Now practically, can you think of a coplanar parallel force system? Can you think of an example of coplanar parallel force system? We just saw the example of this force system, right? We just saw the example of this force system, a car. All the forces that I drew in this car, they were in y direction, vertical forces. So they are coplanar parallel force system. Yes, very good. Simply supported beam. All types of beams, they are usually subjected to parallel forces. So beams are also subjected to coplanar parallel force system. So you will find lot of questions based on this force system in your syllabus. Coplanar parallel force system. In fact, in case of beams, 90% times you will find coplanar parallel forces only. In some cases, there might be a horizontal force also. There might be a couple also. Okay. And otherwise, 90% times beams are subjected to coplanar parallel force system. Yes. Now let's move on to the next one, and this one is the most important force system because you will find most of your questions based on this force system. I don't know why. Maybe it is these questions are so interesting, that's why. Coplanar concurrent force system. Now what do we mean by coplanar concurrent force system? Concurrent means passing through the same point or intersecting at a common point. So this force system, in this force system, all the forces, the line of action of all these forces intersect at a common point. If I draw the example of this force system, let's say this is my body, okay. Let's say there is one force acting like this, another force acting like this. Their line of action is intersecting. So the third force, let's say there is another force. Yes. So you can see that these forces are intersecting at a common point. Their line of action is intersecting at a common point. So this is known as a coplanar concurrent force system. And in your syllabus, you will find lots of questions based on this force system. You will see examples of this force system, okay? Lot of questions. So in case of coplanar concurrent force system, the line of action of the forces intersect at a common point. Okay? Chalo. Now, there are some force systems which can neither be put in this category, nor in this category, nor in this category. It's not collinear, it's not parallel, it's not concurrent. So in that case, we can call it a general force system or a non-parallel, non-concurrent force system. For example, let's say this is our rigid body. There is one force acting like this, there is one force acting like this, there is one force acting like this. So you can see that these forces are neither parallel nor concurrent. So this is known as a non-parallel, non-concurrent force system. So we have these four types of force systems. You can get questions based on any type of force system, but mostly we get questions from parallel force systems and concurrent force systems. Okay, collinear force systems, these are very easy, so you will never get a question from this, and in some cases you might get a question from this one. Okay, now the next topic which we are going to study is a very important topic, and that is resultant of a force system. Now understand what do we mean by resultant of a force system. See, what happens is when a body is subjected to multiple forces, sometimes it becomes very difficult for us to find the effect of all these forces, to study and analyze all these forces together. There are so many forces. Let me give you an example. Let's say that this is a rigid body, okay, and it is interacting with multiple bodies, so it is subjected to multiple forces like this. It is subjected to multiple forces like this. Okay. Now it becomes very difficult if you consider all these forces together and you try to analyze it. So what we do is, in some cases, we reduce the number of forces. How we are going to reduce the number of forces? We are going to add these forces. So these three forces will become one single force. Similarly, we are going to add these two forces. So they are going to become one single force. Similarly, we are going to add these three forces. So they will become one single force. So what we are doing is, in order to reduce the number of forces, in order to make our calculation easier, we are reducing the number of forces, and in order to reduce the number of forces, we are converting them, we are adding them, and we are converting them into a single force. Let's say I want to reduce these three number of forces into one single force. So I am adding them and I am converting them into a single force. That single force is called as the resultant of these three forces. That single force which can replace these three forces is known as a resultant force. If I find the resultant of all these forces, I will get one single force which will replace all these forces. So what is resultant? It is one single force which can replace all the forces of the force system, and the effect of the forces will not change. The external effect should not change. If I find the resultant of these three forces and if I replace these three forces with that single resultant, the external effect of this body should not change. I hope this is clear. So what is resultant? Let's understand the definition. It is a single force and associated moment. I will clarify about this later. Right now just understand this. It is a single force obtained by combining all the forces of a force system acting on a rigid body. Combining means we are actually finding the we are adding them, okay, but it is not a scalar addition. Scalar addition means what? 2 plus 5 equal to 7. This is scalar addition. But if 2 and 5 are vectors, then we can't directly add them. If one is in this direction, another one is in this direction, we can't directly add them, right? If there is one force 2 Newton, another force 5 Newton, can you add them and make it 7 Newton? No. So yesterday we saw how to add two forces, right? We saw how to find the vector sum, not yesterday, day before yesterday, we saw how to find the vector sum of two forces, right? So that was resultant only. If you are adding vectors, it is known as resultant, okay? So resultant is a single force obtained by combining all the forces of force system acting on a rigid body. Now what do we mean by this associated moment? What do we mean by this associated moment? Now let me explain this, okay? In coplanar concurrent force system, you can see that all the forces are passing through a single point. Now, if all these forces are passing through a single point, will they create any moment? Can they create any moment? No. If I take moment about this point, all the forces are passing through it only, na? Their moment will become zero. So these three forces, if I replace them with a single force, I will get only a force. If I calculate resultant of these three forces, I will get only one force. I will not get any moment. But in this case, the forces are passing through different points. They are not intersecting at a common point. So if I find resultant in this case, I will get one force as well as one associated moment. The resultant of these three forces will be a force and a moment. How do we get this moment? Why we are getting this moment? If you are not able to understand from here, when we will calculate the resultant, you will understand. Okay. So associated moment means in some cases when we combine the forces, we not only get a force, we also get a couple. Okay. Chalo. Now the second point, very important point, the external effect of the resultant force and moment on the rigid body is same as the combined effect of all forces. For example, let's say if all these forces are moving the body by 10 meter in x direction, then if I replace them with a resultant force, that resultant force should also move the body by 10 meter. So the external effect should not change, but the internal effect can change. When you calculate the resultant, if you replace the forces with the resultant, external effect will remain same, but the internal effect will change. Internal effect means stresses. Stresses are going to change. That is why in strength of materials, we never calculate the resultant. If a body is subjected to, let's say a beam is subjected to a horizontal force as well as a vertical force. So in strength of material, if I ask you to calculate stress, you will not calculate the resultant of these two forces and calculate stress. No, you will not do that. So in strength of material, why don't we calculate the resultant? Because if you replace the forces with resultant, external effects will remain same, but internal effects will change, the stresses will change. In this case, you will get a different stress, and if I replace them with a single force, I will get a different stress. So that is why you can find resultant in engineering mechanics, because we are only calculating the external effect, but we cannot replace the forces with resultant in case of what? In case of strength of material, because internal effect is going to change. I hope it is clear to everyone. Chalo. Now, what we are going to do is, in all these force systems, we are going to study how to calculate the resultant. Now, in case of collinear force system, it is very easy to find resultant, right? Because both these forces are acting in the same direction. Let's say this is 10 Newton and this is 3 Newton. What will be the resultant? Both are in the same direction. So you can directly add or subtract them. As both are in the same direction, you can directly add or subtract them. So if this is 10 Newton and this is 3 Newton, their resultant will be what? Their resultant will be 7 Newton in this direction. Yes. Very good, very good. So in this case, do I have to explain how to calculate the resultant? Both forces are acting in same direction. You can algebraically or scalar addition or subtraction you can do. So now we will move on to finding the resultant of the other three systems: parallel, concurrent and non-parallel, non-concurrent. Okay. So first we will find the resultant of coplanar parallel force system. Okay, let's find the resultant of a coplanar parallel force system. Okay, now understand how we are going to do it. So let's say that we have a body which is subjected to three forces. Okay, I'm just taking an example. Let's say we have a body which is subjected to three forces. Let's say this is F1, this is F2 and this is F3. And now we need to find the resultant of these three forces. Now as these three forces are in the same direction, y direction, we can easily calculate what will be the resultant force. How? Beta, all these three forces are in the same direction, y direction, na? So what will be the resultant? What will be the resultant? Resultant R will be equal to the scalar sum of these three forces. Scalar sum means what? F1 plus F2 minus F3. F1 plus F2 minus F3. Simple. Right? So you might be thinking, sir, if it is so simple, then why are you explaining this? In collinear force system also we were doing this. Beta, finding the magnitude of resultant is easy, F1 plus F2 minus F3. But we also need to find the position of this resultant force. In case of collinear force system, as both the forces have the same line of action, their resultant will also have the same line of action. So here finding the line of action was not a question. Very good, you understood it. So in this case, finding the magnitude of resultant is easy, but we also need to find the position of the force, where the resultant will act. Will it act at point A? Will it act at point B? Will it act at point C? Or will it act at some other point? So we need to find the position of this resultant force. Let's say this is R. So we need to find the position D. Let's say it is passing through a point D. So how to find the position of this D? So in order to find the position of D, what you can do is, you take moment of these forces about some point. Let's say I am calculating the moment of these forces about some point, any point. You can find moment about A, B, C, D, E, F, G, anywhere you can take moment. Now for our ease of calculation, we will take moment either about A or B or C. Why beta? You can take moment anywhere, but if you take moment about any one of these points, at least the moment of one force will become 0. If I take moment about A, moment of F1 will become 0. So my calculation will be easier. Now understand what I am saying. I am saying that take moment of these three forces about any one point. Let's say that moment is M. Okay. Now if I take the moment of resultant about the same point, I should get the same value M. According to which theorem? According to which theorem? Tell me according to which theorem I will get the same moment of R and F1, F2, F3. According to which theorem? Varignone's theorem. Very good, very good, very good, very good. So how to find position of R? So we are going to apply Varignone's theorem. So according to Varignone's theorem, moment of R about any point will be equal to moment of F1, F2, F3 about the same point. Now this point can be anywhere beta, this point can be anywhere. It is not even necessary that this point must be inside the body. See, there are misconceptions about taking moment. Some people think that we can only take moment about a point inside the body. It is not necessary. You can even take moment about a point 1 kilometer away from the body. So it doesn't matter where you are taking the moment. According to Varignon's theorem, moment of this force R about any point should be equal to the moment of F1, F2, F3 about the same point. But for ease of calculation, we usually take moment about a point where one of the force is acting. For example, I will either take moment at A or B or C, so that the moment of at least one force will become 0. So let's solve a few questions of this force system in order to understand how it is done. So are you ready to solve the problem with me? Chalo. So this is the first question, a very easy one in front of your screen. 3 parallel forces are shown in figure. The distance of the resultant force from A is. See, they are asking you the distance of resultant force from this point A. So what you are going to do first? The first thing is you will calculate the magnitude of the resultant. Draw this force system on your notebook. And find the resultant force, magnitude of the resultant force. Now the resultant force will be in y direction, but whether it will be upward or downward, that I don't know. Although looking at this, you will understand that resultant force must be upward, because 800 and 200 Newton, 1000 Newton is upward and 400 Newton is downward. So if I calculate the net force, the resultant force, it must be upward. 800 plus 200 minus 400. Understand, I have assumed 800 and 200 positive. I have assumed upward force positive and downward force negative. And now I am getting how much? 600 Newton positive. See, I have assumed upward force positive and I am getting a positive value. So now I know automatically that this must be upward, na? I have assumed upward force positive and I am getting a positive value, means upward force, this must be upward. If I assume 400 positive, these two will become negative. So I will get minus 600, and negative means upward. Okay, so I got the magnitude of R 600 Newton and I also got that this R is upward, but I don't know where it is going to act. So let's apply this resultant force somewhere here. Okay, somewhere here I am applying it. This is, let's say, R, which is how much? 600 Newton. Now let's assume that the distance of this is x from A, and I want to calculate this distance. So what I am going to do now, if I want to calculate distance of R from A, I will take moment at A. है ना? I will take moment at A. Now the moment of this R about A will be how much? 600x, right? Moment of this R about A will be how much? 600x, and it will be anti-clockwise. It will be anti-clockwise, right? It will be like this, anti-clockwise. So I have assumed anti-clockwise moment to be positive. Now the moment of these three forces about A must also be equal to 600x. Now if I take moment of all these three forces about A, moment of 200 Newton will be 0 because it is acting at point A, right? Moment of 800 Newton will be anti-clockwise, and anti-clockwise moment is positive. So how much will it be? 800 multiplied by 40 mm. Now the moment of 400 Newton will be clockwise. Moment of 400 Newton will be clockwise. So it will be considered negative. Minus 400 into how much? 30 mm. So from here, your x will become 800 into 40 minus 400 into 30 divided by 600. So how much x are you getting? 33.33. Let me calculate it. Let me confirm it. Yes, 33.33 mm. So now I have got the distance x, means the distance of resultant from A, 33.33 mm. The answer is 33.33 mm. Yes, good evening. So I hope it is clear to you. So shall we move on to the next question then? Let's solve another question. Let's solve this one. Let's solve this one. Two parallel forces are shown in figure. Distance of the resultant force from A is. Solve this one quickly. I hope you will be able to solve it on your own. Here there are only two forces, okay. It's a cantilever type of structure. This is known as a cantilever. One end is fixed and other end is free. So this is known as a cantilever, okay. So in this case, we have two parallel forces, 680 and 660, and they are asking us to find the resultant force from point A. Now, which one will be the answer? A, B, C or D? The resultant force are let me copy this. So first I will find the resultant force, okay. So the resultant force R will be equal to how much? The resultant force R will be somewhere here. Okay, I don't know where it will act. So I am just applying it here. So this is R, and R will be equal to how much? 680 minus 660 means 20 Newton. So I have got the value of R, 20 Newton. And let's say it is acting at a distance x from A. So now what I am going to do? I will take moment at point A. So if I take moment at point A, moment of R will be equal to 20x. And this moment is going to be anti-clockwise. Now moment of 680 will be anti-clockwise and moment of 660 will be clockwise. So 680 multiplied by 300 plus 500, 800 minus 660 multiplied by 500. So x will be equal to 680 into 800 minus 660 into 500 whole divided by 20. So tell me what is the value. 680 into 800 minus 6 into 500 divided by 20. It is 10700 mm. And if I convert it into meter, it will be 10.7 meter. Right? 10.7 meter. So it will be acting somewhere here. Right? Somewhere here it will be acting. Now you must be wondering how the resultant force can act outside the body. Beta, it is just an imaginary force. Understand this. The resultant force is just an imaginary force. It doesn't exist actually. It is just an imaginary force. We are replacing these two forces with an imaginary force which should create the same effect as these two forces. Okay, so that is just an imaginary force. It can act anywhere. Okay. So the answer is which one? C, 10.7 meters. Yes. Chalo. So let's move on to the next question then. Shall we? Now solve this one, and I want you to do it on your own. We have three parallel forces. We have three parallel forces, and we need to find the distance of resultant from point A in mm. One force is 100 Newton, another force is 160 Newton, another force is 240 Newton. Okay. We have their distances from this point A, and now we need to find what will be the distance of the resultant force from point A. Calculate it, beta. Fatafat, calculate it. Okay. So what we need to do first? First we need to find the resultant force. Now you can see that 100 Newton and 240 Newton. These two are acting right side and only 160 Newton is acting left side. So the resultant force must be acting right side only. I don't know whether it will act above A or below A. So I will just assume. Okay. I am just assuming that it is acting below A. Now understand this. The resultant force might act above A also. So if I consider the distance of this resultant force x, now when I will calculate the value of x, if I get positive answer, it means that I have assumed the position of r correctly below A. But if I get negative x, it means that r must be above A. Are you getting my point? I am saying that r can be either below this point or above this point. I have assumed r to be below this point. If I get positive value of x, it means my assumption is correct. If I get negative value of x, it means my assumption is wrong. R must be above A. Let's say I am getting x equals to minus 100 mm. Means R is 100 mm above A. And if I am getting plus 100 mm, means R is below A. My assumption is correct. I hope this point is clear to everyone. Now the value of R. It is very easy to find. R will be equal to how much? 100 plus 240 minus 160. The value of R will be how much? 240 minus 160. means 80 Newton. So we have got the magnitude of R. Now we will find the value of X. We need the distance of R from A. So what I am going to do is I am going to take the moment at point A. So moment of R will be 80x. Now this moment is going to be anti-clockwise. Can you see that? The moment of R is anti-clockwise. Put your thumb at point A, point the finger towards R, move the finger in the direction of R. So it is creating anti-clockwise moment, right? Now moment of 240 Newton will also be anti-clockwise, and moment of 100 Newton and 160 Newton will be clockwise. Moment of 240 Newton will be anti-clockwise. You can see about point A, moment of 240 Newton will be anti-clockwise. But the moment of 100 Newton, it is going to be clockwise. Moment of 160 Newton, it is going to be clockwise. So I have assumed anti-clockwise moment to be positive. So moment of 240 Newton will be positive. So equal to 240 multiplied by, what is the distance? 1200 minus moment of 100 clockwise, 100 into 600 minus moment of 160 also clockwise. I hope you understand this point. Moment of R is anti-clockwise. I have assumed it positive. So moment of 240 is also positive as it is also anti-clockwise. But moment of 100 and 160 Newton will be clockwise. So it is considered negative. Now from here, you can calculate the value of X. So how much you are getting? 240 into 1200 minus 100 into 600 minus 160 into 600 divided by 80. I am getting 1650 mm and my answer is positive. I am getting 1650 mm and my answer is positive. So if my answer is positive, it means what? My assumption is correct and R is below A. If you have assumed R above A, you might be getting the negative value of X, minus 1650. So you will understand that your assumption is wrong and R must be below A. Okay. So in some cases, it will also be that whether it is above or below A. Why I am getting a wrong answer? Have we done something wrong? 340. Okay, it is 180 Newton. Na? It is 180 Newton. Okay. I have done something wrong. It is 180 Newton. R is 180 Newton. Na? Yes, I have calculated the magnitude of R wrong. R will be 240 plus 100. 340 minus 160 means 180 Newton. Na beta? 180 Newton. So now if I take moment at point A, it will be 180x equal to 240 into 1200 minus 100 into 600 minus 160 into 600. So X will be equal to how much? 733.33 mm. 733.33 mm. Yes. Still positive. So the correct answer is B, 733.33 mm. Okay. So if you are assuming R to be upward, you must be getting negative value of X, minus 733.33 mm. So Understood? Chalo. Now this next question is your assignment question. At the end of every class, I will give you an assignment question. I want you to solve this on your own, and in the next class, at the beginning of the class, we are going to solve this question and we will see whether you got the right answer or not. So I hope you like this system. Okay. So we have understood how to calculate the resultant of parallel force systems. But this was pretty easy. In the next class, we are going to see how to calculate the resultant of concurrent force systems and non-parallel, non-concurrent force systems. Okay. Chalo. So I will see you in the next lecture. Those who have joined us recently, let me tell you that we are having live lectures from Monday to Friday at 7 p.m. Okay. It will be 1.5 hour of class, so that you can even watch these lectures if you are a college going student, or even if you are a working professional. Okay. So 1.5 hour of class, it will be enough and you will be still able to manage these classes. Okay. Chalo. So thank you so much. I will see you in the next class. Till then, bye bye. Take care. Good night.